Hello everyone, welcome back to my channel Biostats Inside. Today we are going to discuss descriptive statistics. So let's begin. Descriptive statistics is a branch of statistics that involving organizing and displaying your data sets. So it basically deals your data with a numerical and tabular form. For example, if we have a student and we wanted to know the grade and average performance of a student, so we can use descriptive statistics for the better understanding. Descriptive statistics had multiple categories like measure of central tendency, measure of dispersance, and measure of variability. Measure of central tendency further divided into categories like mean, median, mode. Measure of dispersion or measure distribution divided into symmetric skewness and kurtosis. Measure of variability divided into strength, standard deviation, variance, and IQR. Each and every topic we will discuss in the further and will understand what is this, how to use it, what is merit and demerit, how to calculate. Measure used in descriptive statistics, measure of central tendency and measure of dispersion. Measure of central tendency. So it is a statistical measures that represent single values of entire distribution or data set. So basically central tendency provide you the center value of your data sets. It describes what extent this pattern holds for a specific value. Now, arithmetic mean. It is a commonly used central tendency and easy to calculate where it is calculated by sum of all the values divided by number of values. Formula here it is x bar summation I is equals to 1 to n xi divided by n, where summation represents the sum of values, xi represents the each value in the data sets, n represents the number of values in the data sets. So n is the number of values. Where what is the merit is it is easy to calculate and well defined average, depends on all observations and widely used. Then what would be the demerits is if any of the outlier and extreme values present in the data sets, then it is highly affected by those values. It cannot be calculated if data in qualitative observations are there. Now, examples. If we have five prime numbers, we wanted to calculate the arithmetic mean. So here is the formula. Sum of five prime numbers divided by number of prime numbers. It is easy to calculate. Now, geometric mean. Geometric mean, the first definition that is written here, geometric mean is calculated by multiplying all the values in the data sets and then taking the nth root, where n is the number of values. It is a definition provided in the mathematical term. In the statistics, we can say geometric mean is an anti-log mean of log values. It occurs from period to period, or whenever we have a data in the time period, we can use geometric mean in that case. It is also known as ratio average. Formula: geometric mean is anti-log summation f log xi divided by n, where pi uh, denotes the product and summation denote the sum of values. Xi represents each value in the data set, n is the number of values in the data. Merit: it not affected by extreme values, based on all observation and very well defined. Demerit: if any of the observation is zero, geometric mean would be the zero. If any of the observation is negative, we cannot calculate geometric mean. Now, harmonic mean. Harmonic mean is calculated by taking the reciprocal of the arithmetic mean of the reciprocal of the values in the data sets. Here is the formula. And merits is particularly useful for averaging rates, ratio, and other situation involving inversely proportional values. Demerits: it can be greatly affected by very small values in the data sets. Now, median. Median is known as the middle value of the data set. It divides the data into two equal halves. And for calculating the median, we have to arrange the data in any order like ascending or descending order and then find out the median. This is the process for calculating median. Merits, also called positional measures because it divides data into two equal parts. Less sensitive to outliers, extreme values compared to the mean. Demetric, sorry, demerit does not utilize all data points, which may lead to loss of observations. Uses when data is qualitative, skewed, heterogeneous in nature. If n is odd, if number of values is odd, then median is n plus 1th term divided by 2. For example, if we have a seven five-star hotel, and then we need to arrange it in by the sorting order. Here we arrange it in ascending order and then find out the median. When n is even, then median is nth by 2th term and n plus 2th term divided by 2. So here is the example also that mode is the most occurring value in your data set. In it might be the case that you have multiple modes, because it might be that if you have a data and in the data set there is a multiple observation, multiple values repeatedly there in your data. So it's known as frequency, measure how often values are occurs, represents the highest frequency and possibility of multiple modes. That's known as multimodal. Merit not affected by extreme values or outliers in the datasets. Demerit, a dataset can have multiple modes like mean and median, unique, which are the unique ones. In some cases, data may contain multiple modes, which some dataset may not have any mode at all. Yeah, it might be the case that nothing of the value are repeated, and we can say that there is no mode in the dataset. Here is an example where we have a height of 10 students and we find out that a 90 centimeter occurs the maximum value in the times and mode is 90. Okay, so that's all from today onwards, and we provided the demonstration of descriptive statistics. Further, we'll discuss each and every topic in very briefly, where we tell you how to calculate the descriptive statistics, what are the software you can use, and how to calculate in the software with a specific code also. So as of now, thank you everyone. Bye bye.